Today we're going to be working on two different situations. Our first one that we're going to be working through is fractional exponents, where instead of an integer as our power, we're going to be looking at fractions up there and how to rewrite them using roots, and then how to solve for your decimal as well. So let's go ahead and jump right in. Our second part is going to be looking at the equation of our exponential functions in the form y equals a times b to the x. And we're going to be looking at two different points, and we're going to go ahead and solve them and find that exponential function equation. So let's go ahead and start our notes today. So our very first set is going to be on fractional exponents. And what we're going to do is take a look at a number and then analyze it. So we're going to start with 7 to the 1/2 power. 7 to the 1/2 power. Okay. So as we're going to rewrite this in root format, we're going to go ahead and take a look at these different numbers. So our numerator, in this case our 1, is going to stay as the power of the base. Okay. And our denominator, in this case is a 2, is going to go in the crook of the radical. Okay, so as we rewrite this, we're going to go ahead and make our square root symbol. Our 7 is going to stay underneath the square root. Our 1 is going to stay as the power, and the 2 is going to go into our crook. Now, whenever we have a square root of any number, like the square root of 16, there's always the invisible 2 there. So it's kind of like to the first power, we don't have to leave that there. And we know anything to the first power is 1. So as we take a look at this, we know that this is going to be the same as the square root of 7. So if I have you write the square root of 7 as a fractional exponent, you're going to write it as 7 to the 1/2 power. Now we're going to go ahead and we're going to find out what this is in our calculator. So we're going to go and do our square root, which is second x squared, and we're going to put a 7 in there, and that is 2.64. We're going to round these to the nearest hundredths. So that's going to become approximately 2.65 for the decimal equivalent of 7 to the 1/2 power, or the square root of 7. Let's go ahead and do this with a couple of examples so we can go ahead and get the hang of it. Our next one is going to be 2 to the 4/5 power. So we're going to go ahead and put the 2 underneath the square root. Our 4 is going to stay as the exponent, and the 5 is going to go into the crook. So this is the 5th root of 2 to the 4th power. So that's one way that we can rewrite it. We can also figure out what 2 to the 4th power is, which is 2 times 2 times 2 times 2. And we could also write this as the 5th root of 16. Now, if we then wanted to rewrite this as a fractional exponent, remember we have that invisible 1 there, and that would be 16 to the 1/5 power. So as you can see, there's a whole bunch of different ways to write the same thing, kind of like a fraction, how you can write it as 1/2, 3/6, 4/8, 0.5. So there's a whole bunch of different ways that we can do this. So I'm going to go ahead and do our calculator for the 5th root of 16, because that's a little bit harder to put in our calculator. Now remember, you can use Desmos to do this, and I'll show you on one of them how to use the Desmos online calculator, because it's a lot easier. So if I want to do the 5th root, remember I press your 5 first, then I go second x root, which is your caret, and that tells me that 5 is in the crook there. And then we have our 16 underneath, and we know that that value is 1.74 rounded to the nearest hundredth. Okay, let's go ahead and look at one more, and then we'll go the other direction. So let's go ahead and take a look at 3 to the 5/4 power. So once again, as we rewrite it, we put the base underneath. Our numerator stays with the base, and the denominator goes into the crook. Now, if we were to go ahead and find 3 to the 5th power, that would be 243. So we could rewrite this as the 4th root, oh, that's a 3, the 4th root of 243. We could also go the other direction and rewrite this as 243 invisible 1 to the 1/4 power. So all of these have the same decimal equivalent. So we're going to go ahead and find the 4th root of 243. And that's going to be 3.95. Make sure you're rounding correctly. And there's some great cons on rounding if you need a little bit more assistance with that. Okay, so that's going from a fractional exponent. We kind of did it the other way as well, into a root. Now we're going to go ahead and work that other direction. So let's go ahead and take a look at the 6th root of 2 to the 5th power. Okay, so we're going to rewrite this as a fractional exponent, and we're going to analyze these items once again. So once again, our power of our base is going to be our numerator. And the number in the crook is going to be our new denominator. Okay, so we're going to go ahead and rewrite this. We write our base. Our power is our numerator, and our crook is our denominator. So we would go ahead and rewrite this as 2 to the 5/6 power. Now, we can also solve for this for the decimal equivalent in a number of ways. We can find out what 2 to the 5th is, which of course is 32, and have that in there. And we can go ahead and solve the decimal equivalent that way. So we have the 6th root of 32, which gives us 1.78. Okay, and I'm going to go ahead and show you real fast how you can do this on Desmos before we move to our next screen. And on Desmos, I'm going to go ahead and work on that first problem, the 2 to the 4/5 power. I type in 2, and then I go ahead and bring up my keyboard, or I can go shift to the power here. And we have 2 to the 4/5 power. And as you can tell, that is our answer there. Let me move that around. Okay, and we can look at those other options as well. So I can go ahead and type in, my keyboard can't come up here. If I type in CBRT, that comes up to the cube root, and then I can go in this crook, and I know that my denominator goes in the crook, and then inside I have 2, and then the power of that is going to be my 4. So once again, see that those numbers are the same, so I know that's the equivalent. I can also do the 5th root of 2 to the 4th power, which is 2 times 2 times 2 times 2, which is that 16, and that's another equivalent. Now remember, we could also do 16 to the 1/5. So as you can see, as we're working on these, all of these different items are equivalent, and that's how we're able to rewrite them in a whole bunch of different ways, is because we're not changing the value. We're simply changing the way that we write it so that we can figure out what that is. Okay, let's go ahead and, like I said, do a couple more examples. This one's going to be our weird example. So I'm going to go ahead and do this in purple here. And let's say that we have something like the square root of 5. Now, it seems like, how in the world can we do that? as a fraction. I don't see a power and I don't see anything in the crook. Well, this is where we have to go back to those invisible numbers that are always there. We know that 5 and 5 to the first number, to the first power, is the same because 5 to the first power is 5. And like I said up here, when we don't have anything in the crook, there's actually an invisible 2 there, because I know that what we're doing when we have a square root is we want to find a number multiplied by itself twice and then go ahead and pull that out. So as we have these invisible numbers, we simply pop those in so that we can see how to rewrite that. So as we're looking here, we know that we're going to rewrite our 5. Our power is our numerator, and our denominator is what's in our crook. So that's 5 to the 1/2 power rewritten. And you can also do 5 to the 1/2 power on your calculator, but you need to put parentheses around the 1/2. So if you remember, put those parentheses on there, you can solve in that one as well. And so our answer is, as a decimal equivalent 2.24. Okay. So that, ladies and gentlemen, is the deal with fractional exponents. Nothing difficult, nothing hard, but a couple things for you to remember. Okay, let's go ahead and look at the second portion of our lesson today. And what we're going to do is we're going to find the equation of an exponential function given 2 points. And we've already done this for a line, find the equation of a line given 2 points. But this chapter is focused on exponential equations. And so we're also going to learn how to do that. So we're going to take a look at 2 points. We're going to have the point 1,6 and the point 324. And we know that the equation that we want to find for this, because it is told to us that it's exponential, is going to be y equals a times b to the x power. Okay, so let's go ahead and look at the steps of how to do this. Step 1, we already did. Write y equals a times b to the x power. Step number 2 is to rewrite two equations subbing in x and y from your ordered pairs. And just to make things easier, we always start with our biggest x on top. And you'll understand why in a minute. So as always, I like to write my xy under each of my equations, so I don't forget which is what. That's a silly mistake to make, and just writing xy will eliminate that. And I see I have an x of 1 and an x of 3. So I'm going to go ahead and I'm going to start by substituting in for this equation. So we have a y and an x. So your a and your b are going to remain the same. We're going to plug in our x and our y. So my y is 24. My a and b stay the same, and my x is 3. Okay, now we're going to go ahead and do the same for our second equation. My y is 6. My a and b stay the same. And then we're going to go ahead and put my x in place there, which is 1. Okay. Step number 3. Divide your equations. Okay. So we're going to go ahead, just like we added when we did this for lines, we're going to write a division symbol, and we're going to write the dividing. So 24 divided by 6 is 4. A divided by A cancels out. And b to the third divided by b. Now remember, it's going to look like this, right? B to the third divided by B. These are going to cancel out, and what we have left is b squared. You can also use our laws of exponents where your base stays the same and we subtract our powers. 3 minus 1 is 2. Okay, so either way, whichever one works for you, this one works for a lot of people, is expanding that out. Step number 4, solve for b. So just like our elimination method for lines, what we're doing here is we're eliminating one of the variables, in this case our a, so that we have only one variable remaining. So now we're going to go ahead and solve for b squared. Now the way that we undo a b squared is we do the opposite of squaring, which is a square root. So we're going to take a square root of both sides. The square root and the square undo each other, so what we have remaining there is b. And the square root of 4 is 2. Use your calculator if you need to. So we now know that our multiplier here, or our b, is 2. So all we have to do now to finish up is step number 5. And that is plug in b into an equation and solve for a. So we're going to plug b into an equation and solve for solve for a. So we're going to pick either this one or this one. Now for me, it doesn't matter which one that you choose. So I'm going to go ahead and choose that top one. Like I said, it doesn't matter which one that you use, but I'm going to go ahead and write 24 is equal to a times, my b is 2, so I'm going to substitute that 2 in to the third power. So now we're going to go ahead and solve for a using our order of operations and doing those. So 2 to the third power is 8. 2 times 2 is 4 times 2 is 8. So we have 24 is equal to 8a. We're now going to do the opposite of multiplying by 8, solving for a, which is dividing both sides by 8. These cancel out, so a is equal to 24 divided by 8, which is 3. So now we have our two pieces of information that we need in order to write our equation. We have our a and our b. Our a being our 0, our b being our multiplier. So the equation line that goes through these 2 points is y is equal to my 0, 3, times my multiplier 2 to the x power. So at this point, I always recommend that you check your work. So we're going to go ahead and take a look at this in Desmos calculator. We're going to graph this equation, and then we're going to write these 2 points down and make sure that they are 2 points on the line. So back over to Desmos, we're going to close out our fractional exponents, and we're going to type in our equation. Y is equal to 3 times 2 to the x power. And here's our exponential function. And we're going to go ahead and type in the point 1, 6. And as you can see, that's a point on our curve. And our other point is 324. And we're going to go ahead and zoom out and make sure that that is also a point on our curve. And it is. Now, if I had made an error here, for example, I thought this was 4 instead of 3, as you can see, those 2 points would not be on my exponential curve. At that point, I would go back in, take a closer look at my work, and see where I made that error. Okay, ladies and gentlemen, we're going to do a lot of practice with both of these. They are both new to us. So we are going to make sure that we're feeling comfortable and confident in how to do this. Make sure that you're asking lots of questions in the chat. Because when we have something new, the best way to clarify it in your mind is by asking lots of questions.